For classwork 4-5, we get to learn what is the fundamental theorem of algebra. It's quite fundamental. So I'm going to go over to where I have the answers to these blank spots written in, so I can just point them out to you, and you can nicely read typed answers. So know that a root of a polynomial is where the polynomial has an x-intercept, and we also call it a zero of the polynomial. And just be aware that those three words tend to get interchangeably used a lot. I've seen some graphing calculators that will use the word zero for do you want to find an x-intercept? I've seen some that say root for do you want to find an x-intercept? But sadly, none of them have said, do you want to find an x-intercept? Anyway, when we say x-intercept, though, we're usually referring to the graph. But with the root and the zero, they pretty much just end up fairly interchangeably used. So what is the fundamental theorem? It's actually really simple. A polynomial of degree n has n complex roots. What is a complex? Ooh, it's a number with a complex. Now, the numbers you normally deal with are called real numbers. Real numbers include 0, 1, 2, -1, -2, 1/2, 3/4, pi, the square root of 2, on and on and on and on and on. So we are almost all the time dealing with real numbers. Complex numbers are actually two-dimensional numbers. And the spooky eye, yes. Now, when I say complex number, that actually covers like every number you already are familiar with, plus every number that has an I thrown in it on top of that. So you want to be familiar with the fact that we aren't able to take the square root of -1 in any normal way. But we still have to deal with that situation showing up. And in fact, if we don't deal with this situation, algebra kind of has like a big gaping hole in it. And if you don't use I, it feels like your algebra has some black hole that is scaring you and you just stay away from it. Which is, kind of like what it is. But we call it an imaginary number when we have I multiplied by, say, for example, 2, or I multiplied by -5, or I multiplied by the square root of 3. So the imaginary numbers are when I is just multiplied with a number you're familiar with. And very, very, very important. Complex numbers have the form a plus bi. A represents a real number. B represents a real number. And if we use the letter I, instead of allowing negative numbers under square roots, we get to use all the normal rules of math that we've been using. But as soon as you see a negative under a square root, you need to immediately change it so that you don't mess up algebra, because there are some small differences when the imaginary comes in. So if I showed you a square root of -9, you need to see that that's the square root of -1 times the square root of 9. And then you begin to write that -1 as I, and you will write the number 3i. If I gave you the square root of -21, 21 is 7 times 3, so it's not coming out of the square root. You need to write this as I times the square root of +21, because what we're doing is we're separating the square root of -1 from the square root of 21, and then changing that negative square root of -1 into an I. And I do have a little note down here, because I did say that the polynomial has the same number of roots as it does, as its degree is. Those include all the real numbers we're used to. Realize that when a complex number is a real number, the b right here just happens to be the number 0. So when I tell you that a polynomial of degree n has n complex roots, they might all be real numbers, but some of them could be numbers that aren't real. Now, here's another thing to deal with. If you have a multiplicity going on with one of your roots, so let's say I give you a polynomial. Let me teach it to you, and then I'll tell you later what will be on the test. I know it's confusing. And actually, right now, I'm trying to explain the details of what's going on, and then we're going to hit the algebra. So first of all, I need to explain to you what this fundamental theorem of algebra means. If I gave you the polynomial x minus 1 to the 5th power times x plus 6 squared, say maybe I threw in also an x minus 12, because 12 was getting lonely. What is the degree of this polynomial? I have 5 linear factors that are all x minus 1. I have 2 linear factors, and they are both x plus 6, and I have 1 linear factor that is x minus 12. And if I wrote this out where it didn't have exponents, I would see 8 parentheses across the board with just x plus or minus a number in them. And this may feel a bit confusing, I know, but don't worry. Right now I'm throwing you through some theory, and you may not need to fully understand it, but it's valuable. Now, here's something you need to know. If you have an imaginary number as one of your roots, but your polynomial has real number coefficients. So if the coefficients of the polynomial are real numbers, then every time you have a number with I in it, it has to have its conjugate partner for your polynomial to actually have only real coefficients. And we're going to look at that in just in a moment. But know that each of these conjugate pairs are 2 roots. So when you are told that a polynomial of degree n has n complex roots, that is every one. This actually shows up when you have something like, let's say you had x squared plus 16. If x squared plus 16 was one of your factors of your polynomial, think about this. If I take a number and I square that number and then I add something to it, can I ever make the number 0? If I take a number x and I square it and then I add, I cannot ever be 0, and I certainly cannot have any negative answers come out. But this is a degree 2 polynomial. It's a degree 2 factor. This entire polynomial is degree 3. But this quadratic has 2 complex roots. Actually, it has 2 imaginary roots. And that pair of imaginary roots are a complex conjugate. I also want to mention to you that if you have rational numbers as the coefficients of a polynomial, and you find out that you've got a square root for a 0, its conjugate has to be there as well. So we'll take a look at those. Before I start the examples, and darn it, I'm running out of time, know that if I is the square root of -1, every time you run into I squared, you're squaring the square root away. And if you lift that square root off of the -1, you're left with the real number, -1. And we'll be running into that. So, all that. Hey, question. Did some of you get excited yesterday when you saw that the homework was 1 page and it was only 4 problems? Did you get excited? Or did you know better? Yeah. For math, especially when the homework assignments are short, it's because the problems are so long, I can't give you very many. Oh. Okay, well, maybe it's easy for some of you. Now, I need to make sure you understand what the conjugate is. So, the positive square root of 3 has a conjugate partner root, and that would be -√3. If you have the root 5i, you must also have the root -5i. If you have a root that is negative, oh shoot, you're right, the quiz. Okay, here's what's going to happen. I'm going to finish the notes and put it online for you. You need to watch the notes. I'm not going to reteach it tomorrow. Or you can look at the answers, because I tried to be very, very clear about how to do these problems. So you can try to follow that, and I'll make a video. I expect you to turn your classwork in tonight still. I'm going to first finish up the conjugate thing. If a root is negative root 2, its conjugate is positive root 2. Now these start getting a little bit trickier. Look at the sign in front of the square root or in front of the I. That particular sign has to change to its opposite sign, and other than that, you write everything the same. So negative 2 plus root 3 is the conjugate of that irrational number. 1 minus root 3 is the conjugate of 1 plus root 3. Negative 3 minus 2i is the conjugate of negative 3 plus 2i. So I'm